Mysterious Universe, a Handbook of Astronomical Anomalies. Compiled by William R. Corliss. Illustrated by John C. Holden. Published and distributed by the Sourcebook Project, Glenarm, Maryland. Chapter 2, Vulcan, the Lost Intramercurial Planet. Introduction. It is astounding that astronomers attach so much importance to the tiny specks of matter that circle the sun. This preoccupation with the planets must be the heritage from many generations of sky-watching astrologers. Of what terrestrial import is a minuscule bit of matter in orbit between Mercury and the Sun? Being so near the Sun, it would be almost impossible to see and, supposedly, of no physical consequence to earthly events. Yet anyone who discovered an intramercurial planet would be famous forever. A French physician named Lescarbault claimed to have discovered an intramercurial planet in 1859. The new planet filled an astronomical need. It helped explain the advance of Mercury's perihelion and did not throw Bode's law out of joint. Lescarbault's sighting was therefore almost expected and even welcome. Many famous astronomers subsequently saw this intramercurial planet, and it was given an honored place in the astronomical tables under the name Vulcan. Still, Vulcan was elusive. Organized searches failed to find it during the late 1800s. It had vanished, if indeed it ever existed. The earlier sightings were blamed on misidentifications and instrumental errors. Vulcan became an embarrassment. When Einstein's special relativity theory accounted for Mercury's anomalous motion, reports of intramercurial planets dropped to a near-zero level. A few reports of objects that could be Vulcan still appear, even in recent years. And why not? The solar system contains much debris, and some small chunks may circulate close to the Sun. The early observations of Vulcan. A supposed new interior planet. Anonymous. Royal Astronomical Society, Monthly Notices, Volume 20, pages 98 through 101. 1859. The conclusions arrived at by the distinguished director of the Imperial Observatory at Paris in his recent investigations of the corrections required in the theory of Mercury, in which he communicated in so striking a manner to the world by his letter addressed to Faye, appeared to have already received signal confirmation. An abstract of this remarkable letter was printed in the first number of the present volume, and it may now be acceptable to the readers of the monthly notices to be made acquainted with the circumstances of the observation recently announced. From various accounts received from Paris, it appears that not long after the publication of Leverrier's assertion of the probable existence of a planet or planets interior to Mercury, it began to be rumored in Paris that more than one person had already seen the planet, but that, as is usual, the rumor assumed different forms and was coupled with different names. Towards the close of the year, however, a communication was made of so definite a kind to Leverrier that he considered his official position required that he should at once probe it to the bottom, and take such steps as should prevent the success of any attempt to palm off a fraud on the public. Noting the name and address of the asserted observer, he proceeded on the last Saturday of the year to the nearest railway station to Orgères, in the department Eure-et-Loir, and accompanied by a friend whom he took as a desirable witness of his proceedings, made his way direct and unannounced to the house of Lescarbault, residing at Orgères and practicing as a country physician. A very graphic account of what here passed is given by the Abbé Moignot in a recent number of his useful publication Cosmos, and is stated to be given nearly as recounted by Leverrier to an assembly of friends on his return. Lescarbault was subjected to a severe cross-examination by his unknown visitor, who pressed him hard from step to step till he had obtained such material and verbal evidence as no longer permitted him to doubt the reality of the observation or the good faith of the observer. Not content to leave the question of good faith, where so much rested upon it, dependent on the replies of the individual concerned, he was careful to obtain collateral evidence of the high character and worth of Dr. Lescarbault. Not content to leave the question of good faith, where so much rested upon it, dependent on the replies of the individual concerned, he was careful to obtain collateral evidence of the high character and worth of Dr. Lescarbault from such other persons of station in the neighborhood as should at once satisfy himself and others. and we believe that the precautions thus taken have been accepted as sufficient by all concerned. At the first sitting of the Academy of Sciences after his return, Leverrier announced that on the afternoon of the 26th of March, 1859, a small dark body had been observed to transit a portion of the sun's disk by Lescarbault, which bore all the appearance of being a new interior planet. And at the same time he stated that the observer had made such observations as led to the conclusion that the supposed new planet's distance from the sun was about 0.1427 astronomical units, its period less than 20 days, its ascending node situated at about 13 degrees of longitude, and its inclination between 12 degrees and 13 degrees. Lescarbault has since addressed a written account of his observation to Leverrier, which has been published, in which he states that having witnessed the transit of Mercury in 1845, he had himself at once inferred that the body was an interior planet, and that, living in retirement, he had kept his discovery to himself, in the hope of being able to come to some conclusion respecting its distance from the sun, by calculation or by being so fortunate as again to observe its transit, but that being only a moderate geometer, and much pressed by professional engagements, the problem had baffled him, and he had at last been induced to break silence on reading an account of Leverrier's theoretical conclusions, printed in the publication of Abbé Moigno, to which he was accustomed to subscribe. Lescarbault first detected the body when a little way advanced onto the disk, and inferred the time of first contact by noting the interval which elapsed while it advanced over what he estimated to be an equal space. He then repeatedly measured the angle from the zenith or nadir of the point of the limb to which the body was nearest and its distance from the limb, and watched its passage off the sun. Correcting his measured angles for the angle between the pole and zenith, it would appear that the first contact took place at 19 degrees 4 minutes, and the last contact at 52 degrees 42 minutes from the sun's north point measured towards the west, the greatest distance from the limb being 41.3 seconds, and the times 4 hours 0 minutes and 5 hours 47.2 minutes, or local time, little more or less. The estimated diameter was about 1/4 that of Mercury when last on the sun, and as this was 11.6 seconds, the inference from the statement would be about 3 seconds for the new body, if so small a quantity can be admitted as probable. At the meeting of the Society on January 13th, Mr. Carrington exhibited 2 diagrams in illustration of the original observation and of the inferences to be made from it, and pointed out in detail the very simple process required in such a case for arriving at the approximate elements of the orbit supposed circular. The concluded elements were not sensibly different from those given by Leverrier, except in the case of the inclination, which was concluded to be about 11 degrees 51 minutes. The inclination to the orbit of Mercury was inferred to be about 7 degrees. The remark of principal immediate importance was that, inasmuch as the observation of March 26, 1859 was made about 7½ days before the Earth passed through the calculated line of nodes, and an equal space thereafter was similarly available, it followed that for the space of 15 days at each conjunction the orbit was projected on the sun's disk, and that as the revolution was performed in less than 20 days, it was more probable than not that, unless the original observation were more in fault than supposed, the body might be reobserved in the spring of this year. The attention of observers was particularly called to this circumstance. The days referred to are March 25th to April 10th at descending node, and September 27th to October 14th at ascending node. The singular merit of Lescarbault's observation will be recognized by all who examine the attendant circumstances, and astronomers of all countries will unite in applauding this second triumphant conclusion to the theoretical inquiries of Leverrier. The redetection of this new member of the solar system must next engage the cooperation of observers, and it is hoped that the astronomer at Madras will unite his efforts with those of European and American observers for the purpose. In the 10th number of Professor Wolff's Mitteilungen über die Sonnenflecken, several cases are quoted of the observation of planetary bodies in transit over the sun, some of which are evidently of another character, but the following deserving of attention. On January 18, 1798, Dangos saw a round, sharply defined spot traverse the sun in about 2 hours. On February 12, 1820, Stark saw about noon a singular and well-defined circular spot with indications of an atmosphere, which was not visible in the evening of the same day. At the end of February 1762, Staudacher saw a black round spot, which he missed the next day, and of which he made a note. Might this have been a new planet? At the beginning of May 1764, Hoffman remarked a large round black spot which appeared to have independent motion. On June 6, 1761, Schroeder at Crefeld believed that he saw traverse the sun a round and well-defined spot, 1/4 the size of Venus and as black as that planet when in transit. On October 9, 1819, Stark saw a well-defined and truly circular spot about the size of Mercury, which he could not find again in the evening. On October 10, 1802, Fritsch saw a small round spot pass over the sun. On November 19, 1762, Lichtenberg soon after sunrise saw a large, round, black spot, which manifestly moved before the sun and made its exit after traversing a chord of 70 degrees. The observations of Stark on October 9, 1819, and of Fritsch on October 10, 1802, may prove to be transits at the ascending node of Lescarbault's planet, as the recorded dates fall within the days of visibility. Professor Wolf quotes also an observation of Julius Schmidt on October 11, 1847, but Schmidt himself remarks that the rapidly moving point seen by him was probably an insect or distant bird, and there are no sufficient grounds for retaining his note as of further value. The New Planet, Anonymous, Scientific American, Volume 10, page 323, 1864. Since the brief paragraph was in type announcing the discovery of a new planet, we have received Mr. Beswick's computation of its elements. Mr. Beswick saw this planet cross the sun's disk on February 12, 1864, at 8 hours 20 minutes in the morning. It was then 10 minutes 20 seconds from the eastern limb and 14 minutes 20 seconds from the southern limb of the sun. Its motion was exactly 711.66 seconds in 100 minutes. The whole time of transit was exactly 4 hours 33.5 minutes. The segment of the sun's disk which the apparent path of the body cut off was a complete diameter. Its progress across the sun's face exceeded that of Venus and was less than that of Mercury. Its figure was that of a dark, round, and well-defined spot. Its size was 8 seconds, or little less than that of Mercury at its greatest diameter. Indeed, the whole appearance, figure, density, velocity, and regularity of motion was indicative of its being the transit of a planetary body whose path is included between the orbits of Mercury and Venus. Mr. Beswick cites 6 previous observations by astronomers of the transit of a dark body across the sun's disk, which correspond exactly with the periods of this body as computed by him. The first recorded transit of an unknown body is that of Lescarbault, who saw a round body transit the sun's disk on March 26, 1859, at about 4 o'clock in the afternoon. He and Leverrier computed its orbit and announced it as an intramercurial planet, whose period is less than 20 days and its distance about 0.1427 astronomical units, and Leverrier has given to this planet the name of Vulcan. But the planet's place is unknown, as it has never been seen since. Now, in computing back the times of inferior transit of the body seen by me, February 12, 1864, I find that it would transit the same on the very day and hour when Lescarbault saw a body cross the sun's disk. For between February 12, 1864, and March 26, 1859, there are exactly 14 inferior transits, or 1,784.9 days over 14 transits equals 126.817 days. A circle whose radius is 15 degrees, with the sun as the center, will include the position of this planet up to May 10th, and during its eastern elongation, which will continue to May 17th, it is possible that the planet may show a phase distinct enough to be visible just before sunrise, to a good observer with a good instrument. Its next inferior transit across the sun's disk will be early in the morning of June 18, 1864. So that the planet seen by Lescarbault in France and named Vulcan by Leverrier is doubtless the same planet as the one whose orbit I have computed, and which was seen by me in 1864. But its distance from the sun is 0.4053 instead of 0.1427 astronomical units, or nearly 3 times as distant as Leverrier supposed it to be. And its path, which lies between Mercury and Venus instead of Mercury and the Sun, is 94.1326 days instead of less than 20 days, or nearly 5 times as great as Leverrier supposed it to be. The next observation in going back was that of Schmidt, October 11, 1847, the interval being exactly equal to 33 inferior transits. The next was by both Stark and Steinhubel, June 20th, 1820, the interval being just 80 transits. It was seen by Stark at the next earlier transit than that of June 20th, 1820, on the 9th of October, 1819. Fritsch saw an unknown body transit the Sun on the 10th of October, 1802, and this interval proves to be exactly 49 transits. Finally, the earliest known mention of this body was by Shenton and Crefeld on the 6th of June, 1764, 111 transits earlier than that observed by Fritsch. Planetary spots passing over the Sun. William F. Denning, Astronomical Register, Volume 9, page 287, 1871. I have received from 2 different observers accounts of observations of planetary spots passing over the Sun. I do not think these observations have ever been published, and so send them to you for publication, thinking that they may prove interesting, although I cannot vouch for their authenticity. On August 1st, 1858, 4 hours, Mr. Robert Wilson of Manchester observed the partial transit of a circular opaque body over the Sun. He watched it from 4 hours to 5 hours 30 minutes, when the observation was interrupted. Its motion was from east to west across the solar disk, and it presented an appearance very analogous to a planet in transit. The other observation is by Mr. William Waite of London, who, in a letter to me, states, "It may interest you to know that, some years ago, I saw, what I suppose must have been, a planetary body in transit across the Sun. A dark speck in the lower limb of the Sun caught my eye just about sunset. Thinking it to be a sunspot, I got a glass to look at it, but found it to be a globular body of the apparent bigness of an ordinary-sized marble, and intensely black. I had not time to notice in which direction it was moving, as the Sun dipped almost immediately. Unfortunately, I am unable to recollect what year it was in, but it must have been between June 1860 and June 1863, and I imagine the season was either spring or autumn, as the house fronted nearly due west, and the Sun was setting just opposite. If such things have been seen, they may be seen again, and every additional observation tending to increase such probability leads me to trouble you with this rather lame tale. It is hardly necessary for me to comment on the foregoing, so I leave your readers to form their own opinion as to what amount of reliance it is entitled to. I would remark, however, that the expression, in regard to the object seen by Mr. Waite, as to its size, is a rather vague one. With reference to the object seen by Mr. Wilson, it would seem that it could not have been the planet that was seen by Lescarbault, inasmuch as it was seen in August 1st, whereas it would appear that the latter body can only be observed in transit during the intervals from March 20th, April 10th, September 27th, and October 14th. That is, if the rough date supplied by Lescarbault is reliable.